everyone, in today's video we are going to talk about cleanup of oil spill. We are from group 1-2 and my name is Aliceyanna. Together with me today are Jia Sen, Lee Kiew and Elan. To start off, we are going to talk about problem statement and background of study. Next, we are going to walk you through our proposed method where the source of inspiration and advantages will be discussed. And after that, we will explain further in detail about the methodology, result discussion, and finally conclude our presentation with summary and recommendation. Oil spill has been a major problem worldwide. One of the most well-known oil spill incidents in the recent decade is no other than the Deepwater Horizon BP Gulf of Mexico oil spill. On April 20, 2010, the oil drilling rig Deepwater Horizon, operating the Macondo prospect in the Gulf of Mexico, exploded and sank, resulting in the death of 11 workers on the Deepwater Horizon, hence became the largest oil spill in the history of marine oil drilling operations.
Now, so as chemical engineers, it is our responsibility to tackle the oil spill issue. Otherwise, the effects would be prevalent and also damaging to our Mother Earth itself. Among the most critical problems resulting from oil spill is typically the water pollution, which also consequently endangers the marine life and also wildlife. So now, therefore, our aim in this case study is to propose a method to separate and recover oil spill from seawater itself, which will also enable us to improve the efficiency of oil spill cleaning up processes, as well as to preserve the aquatic life and also the environment. In these days, there are several oil-water mixture separation methods being developed over the past decades. They can actually be divided into traditional physical methods and also complex emulsion method. Now, examples of traditional physical methods are gravity separation, which is also an industrial method of separating two components with the usage of gravity. We also have a centrifuge. We also have a hydroclone separation process, which uses a high throughput device for separating slurry particles based on their weights. We also have absorption and etc. Although these methods are very well established and widely used in these days, they are also considered time consuming and also energy intensive. Therefore, there is another method called complex emulsion method, which consists of electrolytic demulsification and chemical dispersion. Now, complex emulsion method over here would actually have the potential to improve the oil-water mixture separation efficiency, but due to its complexity and high energy consumption, the cost increases, which hinders its practicality and also the capability in oil spill cleanup processes.
Having explored the background of some of the methods available to separate oil spill from seawater, we would like to propose a method called fire-inspired oil-water separation, or simply filtration. It is inspired from lotus leaf, which has super hydrophobic/super oleophilic property, where water will be trapped on top of the leaf but allowing oil to penetrate through. With this inspiration in mind, it can actually be applied to separate oil from water using super oleophilic/super hydrophobic coating instead. Note that the property in the coating is opposite of that in lotus leaf, because essentially we want the water to penetrate through but allowing oil to remain on top so that we can filter out the oil from seawater. In addition, the porous material chosen to be coated is stainless steel mesh. This is because its fabrication method is simple, inexpensive, and environmentally friendly. As illustrated in the diagram, the stainless steel mesh will be attached to the body of the ship to filter out the oil continuously while the ship is cruising in the ocean. The collected oil will then be sent to be refined before being reused. Vacuum dehydrator is proposed to remove the remaining water inside the oil. It raises the temperature while drawing vacuum, which causes water to flash the steam at a temperature low enough not to cause thermal breakdown of the oil. Under vacuum condition, the boiling point of water can drop to around 57 degrees or lower. Therefore, with this refining technology, water can be totally removed from the filter oil before being reused. To explain further about the fabrication technique of stainless steel mesh, a flowchart is constructed. The stainless steel mesh was first prepared and then coated before it was irradiated with ultraviolet ozone treatment and finally sprayed with fluorosurfactant. Fluorosurfactant can provide oil repellency and water affinity, which result in oil contact angle of greater than 150 degrees and water contact angle of less than 5 degrees. Furthermore, we propose this bio-inspired separation method due to its abundant advantages. For instance, it has low adhesion property on the filter surface, bidirectional oil-water separation, excellent efficiency, is easier to be carried out, simple, low cost and environmentally friendly, and collects oil continuously.
In order to further support this method, a series of steps have been developed to prove its applicability by conducting a lab-scale experiment. The materials used are super oleophilic / super hydrophobic coated stainless steel mesh of 70 mm diameter and 30 ml crude oil water mixture with volume ratio of 1:2. To start off, a coated stainless steel mesh filter was prepared and fixed between two glass vessels. 30 ml of oil-water mixtures was then poured into the filter and allowed to separate by gravity. Then, the flux and chemical oxygen demand (COD) were measured. After the separation process has completed, the filter was washed by water and ethanol and dried. These steps were repeated for 10 cycles to test for its durability. From the experiment, we observed that the water permeated rapidly through the filter while the oil was trapped above the mesh. According to the graph, the flux for each 10 cycles were consistently around 140 liters over meter square hour, which means there has been a same amount of water being separated from the mixture. Also, chemical oxygen demand (COD) values for each 10 cycles were lower than 40 mg per liter, which indicates a low oil content in the filtered water. Besides, the contact angle of water in air was consistently found to be about 0 degree, and underwater oil was above 150 degree, which shows a good oil repellency and water affinity on the mesh surface resulted by the fluorosurfactant. After 10 cycles, no structural modification of filter was observed. Hence, it is proven that the filter has high separation efficiency and excellent durability for the practical application in oil spill cleaning up process.
To conclude what we have presented, bio-inspired oil-water separation method is sustainable and environmental friendly. It provides a simple and efficient solution to clean the oil spill where the stainless steel mesh is used to separate immiscible oil-water mixture. What we concern about this method is possible oil contamination on super oleophilic / super hydrophobic surface. Thus, we recommend that the stainless steel mesh to be cleaned or replaced occasionally. These are the references that we refer to, so that's all from us. Thank you.